Thanks, everybody. What I'm here to talk about is Aqua Metals, which has developed a hydrometallurgical technique to recover rare earth metals as well as lead, which we've started with. And with the next slide, you'll see our safe harbor, because we are a public company, which we just, I think, skipped over real quick. That's for you to read at a later time. We're NASDAQ listed, AQMS on NASDAQ. Okay, next slide. So what the existing industry of battery recycling is based upon lead batteries primarily, and we'll talk about lithium in a little bit as an up and coming industry, obviously. But smelting is the #1 pollutive thing that mankind does on the entire planet. So it ranks quite high in terms of the emissions and let alone worker safety and things. And so what you see pictured to the left there is what a furnace looks like that operates at about 3,000 degrees that you need to operate in order to extract the lead metal and really generate a new battery. So I'll show you on the next slide what Aqua Metals has invented, which is totally different. And this is it live in action, Aqua Refining. What you're seeing is one atom at a time, an electrolyzation process through a room temperature and biodegradable organic acid that allows us to electrolyze and first digest and then electrolyze and create ultra pure metal one atom at a time. Very different than smelting, very safe, very low emissions, and really a game-changing step function change in recycling technology. Next slide. This is the product that we produced when we were de-risking and demonstrating the technology in Tahoe Reno Industrial Center, really effectively down the street from the world-famous Tesla Gigafactory. But what we made there were 35,000 ingots. Those ingots are about 63 pounds a piece, or about 55 truckloads of lead. And we shipped those to Clarios, which is formerly Johnson Controls Power Systems Division, and is the world's largest battery manufacturer and an investor in Aqua Metals. We generated those ingots through our process and technologies in 2018 and 2019. Next slide. So Awk Refining does create a high quality, ultra pure product, and it refines it right on the machines. And it really does have a potential to impact the battery world with longer lasting, better performing batteries at a potentially equal or lower cost to recycle. As we continue to evolve the product, we're driving that product introduction cost curve to the point where it's becoming quite competitive with the incumbent methods, and we believe it can become a no-brainer and the best available technology on a global basis. So this will also enable recyclers to meet demand as the lead acid battery industry and the need to serve the capacitization grows, when it's very difficult to pull a permit to expand the traditional smelting types of operations. So let's go to the next slide. We are a equipment supply and licensing company. So a cornerstone of our efforts has been to achieve our global IP with 61 patents that have been issued pretty much everywhere that there's existing battery recycling, and 53 additional applications that are pending. So anything you see there that is dark blue or blue is approved, and light blue is pending. Next slide. So why does lead matter? Some people think lithium's the future. And lithium is a future, and it's a very important future, and we'll talk about that in a moment, and the applicability of Awk Refining to solving the puzzle of recycling lithium batteries. But lithium is going to complement the growth of energy storage with a lot of high growth applications that are out there in the marketplace. On the left, you can see we're putting a lot more cars on the road, and a lot of them still have internal combustion engines. And a lot of those cars that have internal combustion engines now have 2 lead acid batteries rather than one to start the car and one to do the start stop at stop lights and stop signs. energy creation, green energy creation. The wind doesn't always blow and the sun doesn't always shine. So there are massive battery energy storage farms being deployed. Some of those are lead, and some of those are and will be continue to be lithium. The data center space is explosively growing, and they're very large Costco-sized buildings with the hyperscalers, as well as the banks and other institutions that are running the internet to serve the various applications. And those data centers are servers and batteries and generators. So the generators and the batteries keep the servers running when the power goes out. You need a lot of batteries, drives demand for lead acid batteries, as well as lithium batteries. The lead acid battery industry is growing at a cumulative annual growth rate as a mature $65 billion industry today at about 3 to 4%, with about a $20 billion recycling element that is growing in terms of the total addressable market. The last point is that electric vehicles replace the internal combustion engine, but they don't really replace the lead acid battery. The lithium battery propels the drivetrain, replaces the engine and many of the moving parts, but you still need a lead acid battery to manage the rest of the vehicles, such as the turn signals, the computer, the battery management system that manages the lithium battery system, et cetera. So EV growth does drive demand for lead. Next slide.
30-second warning.
Great. Yeah. So this is our impact slide. We're the first of our kind and only alternative to the incumbent recycling methodologies. We've invested over $200 million as a public company and private company, obviously before that, into where we are today. And we're addressing the market through licensing and equipment supply. Now that we've de-risked and proven the technology, we've announced a letter of intent with Acme Metals in Taiwan to develop new techniques for manufacturing batteries in the future. And we're developing safe and clean recycling methods for lithium batteries. Next slide. We're working very diligently on preventing the lithium-ion battery industry from being the other most pollutive thing we do on Earth. There are players that think that recycling lithium-ion batteries is doable through smelting. We think not. We're building on our proven IP. We filed provisional patent, and we've established an eco-network of partners to tackle clean lithium battery recycling. What was our 150,000 square foot Awk Refinery in Tahoe Reno Industrial Center is now being repurposed in a company that we've invested in called Linico, Lithium Nickel Cobalt, that'll become operational very soon. And we'll be adopting our Aqua Refining technologies to go after the multi-metal environment associated with lithium recycling. Next slide is a timeline. We were in revenue when we de-risked the technology. We signed the letter of intent with our first licensee. There's more to come, and we get back into revenue with equipment supply and licensing fees. I think the next slide.
We're gonna
yeah, you can read the press release, and then the next two slides you can see in our website, which is basically our management team and board. You can find that on our website. Last point is things that we're working on: grants, government-backed loans, looking for additional eco-network members, access to feedstock to recycle, offtake of buyers of high-purity metals from our licensees. Open up for questions and answers.
Quick, maybe two related questions for me. I'm looking at the size of those machines and wondering about scalability, but then also wondering about maybe the other side of that, which is deployability. Is this something that you would anticipate being deployed on a distributed basis, or do you see this being, or are there, for example, infrastructure limitations or environmental limitations that mean that this has to be only in certain places?
So our work towards upgrading the existing industry that has a lot of depreciated and amortized smelters, there's about 300 throughout the world. We do that in the form of what's called an Aqua Fit. And that is that we connect into those existing smelters. We take the difficult components to process and divert that through the Awk Refining technology, and it's modular. So what you're seeing behind me is what one aqualyzer looks like, and that's not quite to scale, but it's pretty close. They're not very large, and each one of those produces quite a bit of lead per day. and you can add aqualizers. So as you do an aqua fit and retrofit an existing facility, you phase in the aqualizers as appropriate, and you convert the way that much of the battery recycling is done through this process, which gives you vastly reduced emissions, better relationships with the environmental regulators that have been trying to shut down smelters, the ability to capacitize and feed the growth in the industry, and continue to have a license to operate, and then also develop better performing, longer lasting batteries because they don't have a lot of the impurities, because it's made one atom at a time. So things like bismuth and copper and silver aren't in the material.
Could you talk a little bit more about the timeline to get from lead to lithium?
Yeah, so we're pretty deep into the applicability of Awk Refining for lithium. We filed patents. There's a plant in Tahoe Reno Industrial Center that is now to be owned by Linico. The lithium nickel cobalt is their namesake, and that plant is going to be generating black mass by early 22, so in a matter of months. And we, in the meantime, have developed pilot lab scale versions of aqualizers that go after specific metals such as cobalt, nickel, and manganese, and other metals that you recover from the lithium recycling process with, again, clean hydrometallurgical processes as opposed to sticking them in the furnaces and making a big mess. And the timeline for our development and getting that in the first stages of operation will happen in early half of 2022, I would say. So we're ahead of a lot of the other players that are talking a lot about clean ways to recycle lithium, because there's land, there's a building, there's a plant, there's technology, and there's an eco network of companies. One of the other companies that's involved is Comstock, which you might have heard of. Comstock Mining. It's transitioning to valorization of metals, and they're a throughput company that is one of the major investors into Linico as well. So we believe that not one company can solve the tremendous challenge of the energy transition, electrification. It's going to take a group of companies, which is why we formed an eco network. And what we're looking for and engaged in discussions with are partners that are feedstock, producers, so such as automobile manufacturers, consumer electronics manufacturers, data center operators, wind solar farm operators, et cetera, that need to find where to put these lithium batteries when they're done, so they don't go in the landfill, which is where 95% of them go now. They go into the landfill. The lead industry is 99% recycled. Lithium is not recycled very much to this point in time. So let's build a clean way to do it, as opposed to replicate smelting across a brand new industry that's trying to be the green leaf.
Hey, Steve, this is Josh here from Anzu Partners. I was wondering if there's some cost benefits to this process over smelting, or is this mainly for environmental impact and the purity of the end product?
So right now, we're at cost parity with what we call our 1.25 version of our product, which we ran 1.0 in 2018 and 2019 when we demonstrated the technology at a commercial level and sold those 35,000 ingots to the world's largest battery manufacturer, Clarios. With our continued improvements, we believe that we will drive the cost to the point where it becomes, as I said during the presentation, more of a no-brainer. And the analogy I would give is solar. Solar used to be more expensive per kilowatt hour of production, and now it's the cheapest arguable form of energy creation. And so our intent is to continue to evolve Awk Refining to be the cheapest way to recycle the key metals that are associated with batteries.